Hi, this is Alex from devstories.eu. Rasterio, Numpy for Geospatial Data, Episode 4 of 5. You just downloaded a massive satellite image covering an entire state, but you only care about the pixels inside one specific farm boundary. Loading the whole grid wastes memory, and reading by pixel offsets is useless when your boundary is an irregular polygon shape. The solution is masking with vectors. In a previous episode, we looked at windowed reading. That approach required exact pixel indices, like asking for row 50 in column 100. Masking is entirely different. Masking relies on real-world geographic coordinates. Instead of counting pixels, you provide a vector geometry, like a polygon defined by real longitudes and latitudes. Rasterio figures out which pixels fall inside that shape and handles the complex translation between the continuous vector coordinate space and the discrete raster grid. The core tool for this workflow is the mask function, located in the rasterio.mask module. You pass it two main arguments. First, an open raster dataset. Second, an iterable of geometric shapes. These shapes must be formatted as dictionaries matching the GeoJSON specification. Typically, you read a shapefile containing your farm polygon, extract the geometry dictionary for that specific feature, place it in a standard Python list, and hand it to the mask function. Here is the key insight. The mask function has two distinct behaviors controlled by a single Boolean parameter called crop. You need to understand the difference between simply masking a dataset and actually cropping it. If you run the function with crop set to false, Rasterio looks at your farm polygon and sets every pixel outside that boundary to a no data value. It reads the default no data value directly from the original raster metadata. The output array you receive has the exact same dimensions as your massive original statewide image. The pixels inside the farm retain their actual values, but everything outside is blanked out. The overall spatial extent of the file does not change. If you set crop to true, the behavior shifts. Rasterio still sets the pixels outside your polygon to no data. However, it then discards the vast areas of empty space. It calculates the rectangular bounding box of your irregular farm polygon and shrinks the returned array down to fit exactly within that specific box. Your giant statewide array is physically reduced to a tiny, manageable grid containing just the farm and a small amount of no data padding around its regular edges. Because cropping physically changes the dimensions of the grid, it also changes the geographic starting point. The top left corner is no longer the top left corner of the state. It is now the top left corner of the farm bounding box. Therefore, the mask function returns a tuple containing two items. The first item is your newly cropped Numpy array. The second item is a brand new affine transform object. This updated transform holds the new origin coordinates. If you want to save this newly cropped array to a new file, you must pass this updated transform into your write profile. If you reuse the original statewide transform by mistake, your tiny farm image will be stretched back across the entire state. The real value of the mask function is that it handles all this spatial recalculation for you automatically. Hope that was useful. Thanks for listening, and enjoy the rest of your day.